In order to illustrate the breakthrough in ultra-high spatial resolution partial discharge detection, we've used a classical experimental bench with a high voltage source swinging up to 25 kilovolt, a high voltage cable. We've cut this high voltage cable and we've put at its end an electro-optic probe to sense the vertical E-field component. You can see here the electro-optic probe that is positioned at the end of the high power cable. To initiate more partial discharge, we've used a steam generator, and before switching on the high voltage source, we need to close the electrical cabinet for safety. Now we can switch on the high power source. And you can see on the oscilloscope the sinus is appearing, and here it is the optoelectronic converter on which the electro-optic probe is plugged in. You can see the 50 Hz sinusoid. We are going now to increase the voltage up to 13 kilovolt, and some first partial discharge appear in this humid atmosphere. We are going to check the voltage. The atmosphere is getting wetter and wetter. And at that time, we have roughly sent 6 to 10 partial discharge per period. You can see it clearly on the oscilloscope screen. Of course, as the water is still boiling, the atmosphere is getting more and more wet, and the number of partial discharge is increasing. Now, a couple of minutes later, you can see there is 11 to 15 partial discharge per period. We are changing the time scale to have a better resolution on each partial discharge, which behavior is a perfect single exponential. Now we are going to increase even more the voltage up to 20 kilovolts in a very wet atmosphere. Now the signal is no more sinusoidal, and you can see a huge number of partial discharge. We get between 30 and 50 partial discharge per period. And we are going to make a zoom on the partial discharge. Here it is, and you can see a very nice temporal shape, very classical, of partial discharge. Let's see now how fast is the rising edge. You can see here on this scale that the rising edge is lower than 100 nanoseconds. It is limited by the bandwidth of the optoelectronic converter, which is here LF.